using non-examples to boost students' math achievement. I'll start off just a little bit about myself. I started very early on with a passion in math. I went to the North Carolina School of Science and Mathematics for my secondary school education. Then I went on to Duke University, where I have a bachelor's of science in economics. And then I went to Drexel University to get a credential in teaching K through 6 in the United States. It's in Philadelphia, Pennsylvania. My teaching, the bulk of it was in China. I taught at the Shanghai American School, as well as the International School of Beijing. So I taught mostly primary grades. But my last couple of years, I got a credential as a math specialist in international schools and was a math coach and worked K through 12, writing curriculum, scope and sequence, doing a lot of workshopping with teachers and teaching math, going into their classrooms. So this is pretty nice to kind of go back to doing something like that. And now I'm here at Ed Rollo, like Clinton said, where I'm heading up the junior math team. All right, so what are we going to talk about today? So we're going to talk about what and why. So what's a non-example? Why do we want to use them? You already have so many things that you're doing in your class, so why would you want to add something else? I'm going to show you how to use it in your classroom, techniques and strategies that you're probably already using, and how you can just upskill those a bit and get the most out of it. And at the end, how to plan it into your lesson. So hopefully you get some tangible things that you can take away at the end of today. All right, so what is a non-example? So if you think about some scenarios where the best way to understand something is to understand what they are not. So what is it not? Basically, opposite to examples, non-examples will provide concept boundaries. For example, here we have probably something that you do every day in your math classes where you're showing how you would solve this. Basically, we're going to dive deeper into some of these. It's good to be able to see what it is and what it is not, so that you give some boundary conditions to the concept that you're teaching. So why do we want to do that? Well, if you think about your brains and how humans learn, we have a brain schema. So you can think of the schema as some file folders in your mind, and you start creating these from very early on in your life. And how you create and how the brain creates these is by having the examples and the non-examples. So as humans, our brains develop by recognizing patterns, and our brains are actually constantly seeking patterns in order to learn. So if you think about the knowledge that you have in your head, a lot of it is from what it is and what it is not. And I have a little bit of an example that we'll show you. So activating your schema. So your schema is what you already know about that topic. And then when you want to activate it, you're basically going into the file folder to take it out of your mind and to use it. This is what we are doing as educators with our students. And even when they're in secondary school, they already have pretty much a very full file cabinet, but we can still add more. All right. So here's an example about how we learn. So think about a newspaper. We can all see this and we see this is a newspaper. But what is it about the newspaper that makes it a newspaper? Kids today probably don't even know what a newspaper is, but there's things like the titles, the font, the pictures that they use, and also the way text is written. These are all things that make a newspaper. When we learn this, we're using generalizing. Generalizing and discriminating experiences from observations. This is what we use from examples. So we do this a lot as math teachers. We give examples. Students are generalizing, they're discriminating, they're basically creating part of their schema. If you also know about discrimination, our brains are also learning from discriminating. If you look here, sorry. Here's an example of something that a newspaper is not. So if you look at the text it doesn't look the same, right? You look at the pictures, they don't look at the same. If you look at, this is another example of a book. It looks very different than a newspaper. In order for us to learn what a newspaper is and isn't, our brains have discriminated what something is and is not. So this is an example of non-examples. How about non-examples in math? So abstract concepts like mean, median, and mode, they're better taught by discriminating between examples and non-examples. So when we have clear, distinguishable math skills like addition, subtraction, multiplication, these things that are easily shown by an example, that's enough. But there's some concepts that it is actually better to show what something is and what something is not. I'm sure if you guys are all, not sure what grades you guys are teaching, but mean, median, mode is something that I think students struggle with. Sometimes I still even struggle with it as an adult. So here's another example of where you could show where something is not and where something is. This is what we were talking about, misconceptions that students have. So a lot of the time students assume that, I'm not sure what's happening here. Students assume that the mean and median are always the same value. And here's an example of where they would make the mistake. And so by showing students what the example actually is, but what the mistake also is, that helps them with understanding the boundary conditions of that concept. So a good non-example should vary in one skill to clearly discriminate what the skill does not look like. So for example, if we look at this example of birds, so there's standard birds, non-standard birds, and a non-bird. By making sure choosing which non-example that you want to use is almost as important as choosing what example you also want to use. So you want to make sure that you're not varying in all different types of skills. You're not trying to show too many things in one example, but the actual skill that you're trying to target, when you vary that skill between the example and the non-example, that is what helps students learn best. I don't know if there's any questions so far, but pop those in. If we look back at Bloom's taxonomy, which as educators we're probably very familiar with, the use of examples and non-examples is up at the top here, where we're analyzing, students are analyzing and evaluating examples and non-examples in order to then create their own examples and non-examples. By the time that you're in secondary school, this is pretty much where we want to get the students with their learning, to be able to take the knowledge and then create something with it. So that's pretty much the basis of why non-examples are really important to use in our classrooms. And then now we're going to talk about how we're going to actually use it in the classroom. Is there any questions? Yep.
Yeah, I see, Kathy, that Candace is just typing. So
yep.
I'll just give a second and then if it's relevant to this section before we move on. No pressure, Candace, in terms of typing speed.
It was just a very quick sort of brief.
Of course, and apologies again that we can't just switch your cameras on and switch mics on just to make it a little bit easier, more conversational. If we weren't in the meeting already, I think we'd be able to set it up to do that, but it gives you a second to have a drink of water anyway.
Yeah. It's really hard when I can't see everyone to know my pacing. So if I'm going too fast, please also let me know if anyone wants to go back and look at any of the slides from before.
So I'll read out. Can you see Candace's comment, Kathy, or do you want me to read it?
Oh, I can't see it. Sorry.
Okay, cool. So I saw a video once that made it easier to identify the mistakes by giving students a warm-up question that they answered on a slip of paper. They picked their favorite wrong answer to show all the students so they could see the non-examples. So it's a nice example of a strategy.
Yeah, that's a great strategy to use, and definitely using a non-example as your hook and as your starter in the classroom is a great way of teaching, of showing what something is not. That's actually a great strategy. Thanks for sharing that. All right, so this is sort of what we're talking about, how to use it in your classroom. So it's a combination of direct instruction. That's where you're choosing which example and non-example to use, and handing it out, and indirect instruction, where students will then create their own examples and non-examples. And this is through a lot of teacher prompting. So this really comes by exposing students to a very wide range of examples and non-examples for them to see, and then to discover the content and make the understanding. So this is sort of that shift of where it's very teacher directed, where you're writing the examples and the students are writing it down in their rule books, of flipping that classroom and really being a facilitator in the conversation. The great thing about secondary students compared to primary students is that you can actually have some really deep conversations. And we're going to talk about some of the prompting that you can use that will be helpful in class. I'm not sure why my slides keep moving that. So direct instruction is analyzing and evaluating. This is pretty much your traditional worked example, what a lot of you will be using in class, where there's a prompt, you show the working and the thinking. This is sort of an example like what Candace just shared. This is a section in our Enrolla textbook called Spot the Mistake, where we really point out what is the non-example. So what did they not do correctly? We actually explicitly ask for students to find out which student was incorrect instead of finding which student is correct. So this is a great non-example that would be on the other side of, okay, so here's the worked example, it's what you would do. Now, given this situation, who would be correct or incorrect? A tip to remember, though, as we know now, we have a lot of students, so neurodivergent students and EAL students may have more difficulty in recognizing patterns independently and may need some appropriate scaffolding. So if you do have students who are in either of these categories, some of what you can do is really step out a bit more of highlighting, okay, what was incorrect, why was it incorrect, and just scaffold it a bit more for them. Here's an example of examples. So traditional worked examples highlight a specific skill, and that is the misconception of the skill. And targeting that misconception can be used in your classroom as a formative assessment. So in this example, as you see here, a lot of times we know in algebra, just understanding the right-hand side and the left-hand side and doing both on both sides is a huge misconception. And this is an example of where we're just targeting one skill. We're showing them, okay, you need to balance both sides. And then when you do that, if you have students in your class at the beginning of the class, kind of like what Candace was sharing, you can really target, okay, which students need more help on this skill, which one when they don't. A lot of times what I've heard in Australian classrooms is, you know, it's very assessment based, but it sounds like a lot of summative assessments. So what could teachers use as formative assessments? Often I think it's overlooked that the theory part of your classroom, when you're teaching examples, this can be also used as a formative assessment. So you see here, this is where you're highlighting the skill. Here's another example of a worked example. This is one from our Enrolla textbook. As you see here, the misconception that a lot of students have is usually counting the number of bases when they're doing indices. And so this is a visual model that is actually, besides just the written theory, the visual model, which will help students to actually see how it's stepped out, how the working is stepped out. This is a really good example of an example. This is the misconception that's usually tied here, where it says that students don't include the base number when writing the number in index form. So you can show what something is and is not, and then that ties well with your worked example and visual support as well. So indirect instruction, this is personally what I always find to be the fun part, is really based on the inquiry-based approach. And at the end, you really want students to be able to create their own examples. And like I said before, it's really based on this whole idea of mathematical discourse and prompts. So the prompting is really important, where teachers are really asking those questions of what do you see, what do you notice, you know, then presenting non-examples and saying, okay, now what do you see? What do you notice? What's the same? What's different? And the most important question always to ask students is why. So really pushing them to justify their answers of why is this correct or not correct. All right, so now we're gonna try some. Here's an example of where we're talking about ratios for angles. And this is probably something you would do in your class. And then this is what's really a great sort of way of taking your examples to the next level. So in order for student engagement, working in pairs, working in small groups. I went to a school observation where they also use this sort of as four corners in the classroom. And so you could take little groups of students and put them in the four corners and then have them is really with these targeted questions, like where did these numbers come from? You know, if you're using the box model, how many would you draw? Where would you put them? How many degrees? So all of these questions really sort of to get them thinking. And then having them create something after. So giving them, this is also scaffolding out like what would be the largest angle, what would be the smallest angle, and at the end, they're sort of coming up and creating their own. This is really powerful. This could take up half of the class. This really promotes conversation. You can get a lot of anecdotal information out of it as well, and really support students to solidify their foundational learning before they just go off and do fluency questions in the classroom. I'm sure, as you all know, and we've been seeing in the news a lot, like once the kids are off and just doing and not engaged, you can have a lot of behavioral issues. So this is a great way of getting students engaged in the work and also coming up with their own learning. So this is a great example at the end to come up with what would be a non-example to this. So creating them to come up with their own boundary conditions. Here's another example with using a pretty abstract concept. One of the things that I hear the most when I talk to teachers in Australia is, you know, we just don't have a lot of time. There's a lot of students. There's a lot of content to get through in your curriculum in a year. There's a lot of kids who, you know, coming out of COVID, a lot of behavior issues, that there just isn't time to use visual models or to have any sort of discourse in class. And I think it's sort of a misnomer, like a lot of you're already doing it. You know, you're already doing it in your examples and in your teaching. It's just taking it to the next step of scaffolding out, like what could students be using and then what could they be doing? As Clinton said, in the end, we will share these slides with you guys. So I put these in here as examples that you guys can hopefully go and use and try in your classroom. This is another example of something that's called the Freyer model, which is used a lot in vocabulary and vocabulary learning across all subjects. Probably a lot of it was mostly seen in English and maybe science at first, but it can definitely be used in math, where you are talking about a concept or a skill and you define in your words, talk about the characteristics, and give examples and non-examples. This could be used as a starter task. This could be used if anyone, I'm not sure if teachers here still use Kahoots. This could be made into a Kahoot, which is very engaging for students at the beginning of class.
Kathy, I asked in the chat if anyone had tried anything like this in their junior maths classes. Yeah. And Candace came back and she said, not yet. I feel like I need some template slides. Yay, she's very excited to get me started because she wants to be doing things like this. And Chloe is in the middle of writing something, so I'll come back to you.
Okay, great. Yes, definitely. I think like this is what I was saying is a lot, you know, it's out there. A lot of times teachers tell me, you know, we do use this a lot in primary, but there's no reason that it can't be used in secondary schools as well. Especially in junior math. You know, I think we all know coming out of COVID that, you know, especially grade 7, grade 8 students probably need a lot of this just foundational learning that they didn't have.
Yeah, so Chloe's just said she hasn't explicitly ingrained. She finds with lower ability students it can be quite difficult for them to understand, and I've generally taught students who have additional needs. These resources are definitely helping in understanding ways I could be incorporating it though.
Yeah, definitely. I mean, I taught learning support for many years in my classes as well, and a lot of these activities or strategies or ideas came from that also, because you really are having to scaffold down to the very basics of, okay, like what is it? You know, and even in a class, you may not get through all of this in one class. I know a lot of teachers say, well, then I don't have enough time, but you could take into like, okay, here are the definition, here's what it looks like. And that may take, you know, a lot of discussion or examples, hands-on manipulatives. And then as an exit ticket, so when they leave the class, you could have them sort of fill in, okay, what are examples and what are some non-examples? And that's another great formative assessment you could use.
And Candace has just added to that it explains a lot when you say primary do this. She's only secondary trained and she doesn't see many teachers doing this in the secondary space. So I think that's exciting that like it's going to filter up.
Yeah, I mean, I know as I've been in Australia now for almost 4 years, and so a lot of people are like, oh, that's just primary, it's primary, and I don't see why you can't use it in secondary as well. As I was chatting with Clinton earlier, I have a year 10 student, a 15-year-old and a 13-year-old, so year 10 and year 7, and often, you know, and my year 10 student, like he definitely has gaps in his learning. He was home. He was actually in China, so he was in school, like at home for almost a whole year and missed a lot of school. And this is a great way to actually get them engaged with the concept as well. Like I've seen him when he's just doing fluency questions at home, he's very tempted to go to the back of the book and write down the answers. But to use this as a way of like, oh, okay, like what does that actually mean? He actually is engaged in it. I don't know if it's also his mom writes math resources. But.
Finally, Chloe said she loves that idea of an exit ticket to distinguish their understanding.
Yeah. I mean, the exit ticket is just such a great way of, you know, like I used to use, but I actually think, you know, secondary, you could use it as well. Like I used to have like just a little box. It was very cute, quite decorated, and they would take their little exit tickets and they put it in like a little box at the end. And then it's just fun for them as they're walking out, and it just makes the class just a little bit more engaging. So we talked about prompts. So planning specific prompt, it really guides the students' learning and provides scaffolded thoughts. So the prompts are quite important, just as important as choosing which example and non-example to use. So we talked about these, like, what do you notice? What's different? What's the same? What happens when, and then you insert the skill. So for example, algebra, you know, at the junior level, just understanding that balancing of left-hand side and right-hand side is such a hard sort of concept. You know, even my 15-year-old last night when he was revising for an exam and was trying to like take something away from the left-hand side, he's like, wait, why am I doing it here? So it's really trying to understand that, you know, what happens when I just subtract 3 from the left-hand side, but do nothing to the right-hand side. So getting them to think, you know, one, it's okay to make mistakes. And it really is that growth mindset sort of thinking, you know, like it's okay to make mistakes. And what do you learn when you make those mistakes? And getting them to articulate it and talk about it. So prompting conversation is just as important as the example. So I found this example. So a lot of visuals are actually great examples. You know, so here's an example of something you could put up, like, there's a boat, but there's no water. There's a random rocket flying. It's, you know, what if you just showed this to students and gave them no prompting, they would have no idea where to come, you know, with. But if you ask them, okay, it's just starting off, what do you notice? Just writing out just what you notice. What do you see? You know, what's same, what's different, and then getting them to understand. It really is unlocking the power of understanding from using non-examples by really getting them to articulate what is different. Okay, the next part that we're going to talk about is targeting misconceptions. This is by knowing and identifying what are misconceptions on a topic can really help you as the teacher to sort of guide your lesson and to see where students are falling down. It can really help you to target your instruction, especially if you are in those lower end classes or also even on the higher end extension classes. By understanding what the misconception is that students are having, it will really help you to really understand where are they falling down, how can I fill those gaps, and what you should really be teaching. This is another example from our resource. At the beginning of each chapter, we have misconception tables, which list out for all of the lessons the misconceptions that students have on the topic. And we always give a non-example and an example so that both you, the teacher, and students can see, okay, this is what it looks like. We did get some feedback before when I had teachers say, why would you want to show a student, the mistake? We really want to show them only the correct working. That's one example of, yes, that's something we want to show. But as I said at the beginning, when I went through the theory really quickly, it was based on cognitive load theory that students only can learn a certain amount. And then after that, there's just everything excess, is not going in. So you really need to set those boundary conditions. And that's what showing the incorrect, like this is wrong and this is right, really helps to set that. So examples and non-examples are not just in working. You can also use it to highlight patterns of processes that students struggle with. So in our resource at the back for problem solving, we have explicitly written out these answers. So it's full working, but the highlighting is really important. And this is something that you could do with the resource that you have right now as well. But this connection of showing, okay, which are the pieces of information and how is that used in my explanation to do my calculation to come to the final answer. This is really important in that you can actually break down and you can see, okay, where in the process of thinking are my students falling down? So a lot of times is we focus on the skill, we focus on the fluency. I know my kids' homework are usually only fluency questions, but you can also use this with problem solving and reasoning because math isn't just about fluency, but it's also the whole mathematical reasoning, processing, generalizing is just as important.
I can see, Kathy, also because we had the session yesterday with our science colleague Felicity talking about literacy strategies. I could also see how this approach in particular would be really supportive, particularly to students who may be either EALD learners or low ability or perhaps fallen behind for whatever reason. Like it really, like especially for worded problems where students can struggle, right? Like I could really see how this would kind of unpack that for them.
Yeah. And it's, just very easy. You can do it now, in class, even just by modeling to students, how to highlight and where actually that piece of information goes. And how you would use that as a non-example is that you could actually make the mistake, like in your highlighting. I've done this a lot, like when I was doing the coaching and I worked in the middle school and high school. High school kids love it when you make a mistake and they love when you point it out. So if you purposely make a mistake and you're showing in the process where you fell down, they can get a lot of learning out of that. So really highlighting those patterns is really important. All right. So we're sort of moving along to how to plan this into your lesson. So varied examples are really important. It really helps to draw the students' attention to the deep structure of the content. So definitely there's traditional worked examples that you use, but also by contrasting with non-examples, and like I said, drawing students' attention to the boundaries of the concept. And then using questions that promote the discourse, that elaborates about connections and differences between the examples and the non-examples. So if you go into your lesson planning sort of with this lens of, okay, this is how I want to run my class, these are the things that I want in order to teach the concept, a possible sample lesson that you would do is really think about the misconceptions first that we talked about. So like here in this example, we talked about, this is with the indices. So very often students use repeated addition to express the numbers in expanded form instead of multiplication. You would show this in a worked example of like, this is how you would do it. You could then move on to talk about, oh, sorry, the key ideas. Sorry, not sure. Here we go. Oh, yep, the key ideas of that topic. And then this would sort of be like the theory that you're thinking about, and then really asking those questions to students when you're showing your example. If you start using those question prompts, and even if you have your key ideas here, just talking about, okay, why is 8 the base? Why is the index 3? You know, oh, it's 8 repeated 3 times, or 3 factors of 8. Really using that to get the students to be talking about what is the learning will be really helpful. So a good non-example should vary in one skill. That's what we talked about before. So here's that sort of spot the mistake place that we were talking, question that we have in our resource, but it is like sort of what Candace was talking about before. You know, like what's the wrong answer? There is a lot, and I cannot stress enough, like how much learning comes out of identifying what is incorrect and getting students to articulate why that is that way. Also making it sort of fun like this with these little students here and trying to find out who made the mistake is quite engaging for students as well. So you would ask them, you know, what do you see? What do you notice? How are they similar? Right? What would they do that's correctly? How are they different? So what is the mistake? And then again, getting them to articulate the why. So here's some templates to use for students in class. This is one that I showed before. And when we send it out to you, I'll put in some blank ones as well that you can, I think it'll probably be sent to you out in the slideshow format. And then you could use them, and it's something that you could project, you know, online for your kids to use, or you can also print it out and they could do it in class. Here's an example. This is actually from one of our online resources that we have. We have teacher videos, and we use that. This is another example of the Frayer method, but in this for math. So as you see here, we're talking about coordinates, and we use a story to illustrate how these coordinates could, you know, be in a worded problem. We show how they visually are represented, how it's represented, and also numerically, how would you find gradient? How would you find coefficient? Why is it that lines like this is actually, they're not in order, but they actually have like gradient. Why is it rise over run? I mean, there's so much learning that can come from using one of these models. And then at the end down here where he talks about misconceptions, this is sort of the non-example, right? So this is, what is it that you've done wrong and why is that important? So I have sped through that. And this is some information of non-example resources. And then this is my contact if you have more questions. This is our website and how you can find us on Twitter. And I finished quite early, sorry, Clinton. If there's any questions or comments or discussions, or do people want to know more about something, I can expand more on a specific topic.
There's some, Candace is typing now, Kathy, so
okay,
just hold on a second.
Yeah. Let me see if I can pop
just
over.
while Candace is typing, like, are there particular topics or areas where you see this easier or work better, Kathy? Like, are there things where, like, you know, doing this for the first time as a teacher would be like, you may maybe start here because it's going to kind of be a bit easier and a bit safer to get started?
I definitely think it depends on what you're more comfortable with. So if you've been teaching quite traditionally and you're comfortable with, you know, algorithms and just calculations, it would be very simple of just pointing out, okay, why was this my calculation incorrect?
Mm-hmm.
You know, like why were Does something come up in the chat? I can sort of see something sort of popped up. But
yeah, Candace has said, any tips to avoid confusing students more? This is sort of what I've just asked, which is it's a bit similar, isn't it? It's like, how do you do it well? How do you not? Yeah, especially if students are struggling. Like I think what Candace is saying, you don't want to confuse them more.
I think definitely starting out small. So in one of my first examples of just pointing out like what is the actual, so if in the calculations, like in algebra, when it was adding something to the left-hand side and then to the right-hand side, is actually highlighting that and then showing, okay, so they missed. What did they miss, right? Why is my calculation incorrect? And starting out with something like that. I think using visual models are very, very helpful. So like if you're doing fractions and you can draw the picture of like what is, a third and what is a half and what is an eighth. And then you can show like, why is it that when the denominator becomes larger, the actual pieces of the fraction become smaller. So it's really going to be targeting, like we said, that one specific skill. So a good non-example targets one specific thing, and that's what you want to highlight. So if you think about, you're often thinking about what example you're going to use, right? Because that's the skill that you want to teach. So basically, you want to think about what is that main mistake of where kids would fall down, and that would be the non-example. So that's what you would want to show. You could also start off, sort of like what Candace had said, is start off with the mistake and be like, this is incorrect. Tell me why is it incorrect? And then show the example after that. So use the non-example as leading. That could also be a good way of starting and using that.
Such a great way to start discussions in your class too, and really pique that interest in what you're learning about, right?
Yeah. I'll go back to this example that I had up here.
Chloe also said she was just about to ask if you had any suggestions for fractions, because that's what she's teaching at the moment. So that was well timed.
Yeah, we actually have some great things for fractions. I should pull up the other presentation, Clinton. But for fractions, what's great is using a lot of visual models. I don't know if you're familiar with fractional arrays, and I can actually pop that probably a slide or two into this when it gets emailed out to you, so you can take a look at it. But basically using just grids where, you could even use 100 grids or 10th grids, you can find them online, and basically showing students of how, you have a whole piece, and then it gets divided into tenths or hundredths. Because one of the main misconceptions that students have with fractions, it's a whole number misconception. So kids learn, from a young age, all about whole numbers, like 1, 2, 3, 4, 5. And then now we're showing them that, oh, okay, so like 1/8, well, 8's a bigger number than 2, so shouldn't that fraction be bigger than 1/2? And this is a big misconception. So using visual models, manipulatives, any sort of hands-on, even just taking, like a piece of paper and being like, oh, I have a piece of paper, and if I just fold it into 2, right? Now I'm folding it into more pieces. What's actually happening? My actual piece is getting smaller. Is a great way of targeting that misconception.
Nice. Chloe's got, she's typing something else in there as well. I took in fraction circles the other day, and they had so much fun making equivalent fractions.
Yeah. Fraction circles, those are great also. I had a bad experience with circles because sometimes they're hard. Actually, we had some where students were making them and they sort of get off, but it's actually probably because they were grade 3. But I just love, a rectangle or a piece of paper. Like, it's so easy and handy to have.
I also feel like I have trauma from fraction circles teaching primary.
Because they can't gut a circle. That's the advantage of secondary.
They can never do it equally.
A fraction wall is really good too, Chloe. I don't know if you've seen them. There's a lot of those online where they actually have like the whole bar that goes across as 1, and then they have the wall, and then you can see sort of like a half, and then a 1/4, and an 1/8. That's a great thing to do as well, or cutting strips. Yeah, that's great. Chloe, what grade do you teach? Do you teach 7 and 8? I've just opened up the chat now so you can see. Oh, 7, 11, and 12. Wow, you're on both ends. Yeah, that's pretty good. Yeah. So you probably see like where if you can target all of those things foundationally in year 7, that by the time they get to year 12, they don't really have those misconceptions embedded. So it's probably better for their learning. It's also why like in primary, it's really good. But this is the example I was talking about before, where like this is what we're trying to target in the skill with algebra, right? It's like having them to understand that what they do on the left-hand side and the right-hand side, you need to do it both ways. And this is an example of, like, I didn't put anything really that was a visual in here, just as this is something that you're starting out with. It probably looks like the traditional examples that you've been using in class. But the way that you could use this to talk about it is when you're doing the example, if you purposely make a mistake, get them to call that out.
Chloe's just writing another something else.
I was going to ask Kathy, like where in the sequence, or does it matter in the sequence of teaching and learning where you do this? Like, would you tend to do your kind of maybe more traditional kind of theory-based instruction and then use the non-examples to kind of almost like deep dive and steer students away? Like, or does it matter? Is there a kind of...
I mean, it doesn't, there's no right or wrong way to do it. I've just found it more successful to actually start, it's more of a hook to start with the mistake. So if you think of like the lesson plan, it would be more of like, yeah, like where is the misconception?
Chloe said, I had year 11s last year who didn't understand how inverse operations work. So it's great to be able to target these gaps earlier. I'm definitely a traditional examples person, never purposely making mistakes, but they love pointing out my accidental ones. I think they'd enjoy getting to not only point out these on a more regular basis, but also how to create their own.
And explain them, I think, as well, isn't it? Like that's kind of part of the point, is what's point them out, and then like unpack why.
Yeah, the why is really good, which is why on this one, hold on, let me get the next.
There, it's on the slide.
Oh, was I on mute? Sorry.
Oh, I thought you intended it. I was about to point them out, but.
So this is a sample lesson. How I would do it is basically, if you use this first, coming up with your examples, this is probably more of your traditional way. I would actually, just because it promotes conversation, I would show probably a mistake first. That's how I would do it. But I know that it's very, I would say just try it in your class, because I know a lot of teachers are very worried that they're embedding a misconception. But that's why if you really talk about the prompting, I made a mistake here. Why was that the mistake? And that really gets them to articulate it sort of like from another way, like we said about having those boundary conditions of why that was incorrect. Because often, I've seen even with my own kids, you know, you put the example and they copy it down, but then you ask them, well, why is it, what, like, why do you do that? And they're like, I don't know, the teacher just told me to do it that way. So I would do that. I think it's really important in knowing what those misconceptions are, like targeting those misconceptions before you start your lesson. So if you know that, okay, oftentimes like students use repeated addition instead of multiplication, that's something that you'll be able to target when you first start. But like anything, I always say, just try it. Like you never know until you try. And that's the great thing about being a teacher. I do miss that in the classroom, is you can try things and they might not work, you know? So I'd love to hear if you try and like sort of what your feedback is on if it worked or didn't, you know, work very well. I can always send you more information also, like definitely. I think an important thing also is the whole creating your own, right? So getting like, this would be an example from a textbook, but you could also get them to write their own questions. So it could be from other examples. So if they're doing fluency questions in class, so they could come up with their own, Or another fun thing that we've done before, even in secondary schools, is creating little quizzes. So if you pair them up, they write a test for each other, just some fluency questions, and then they have to check each other's. And so basically they're checking for what's wrong. That's also another great thing that you can use in class.
Nice. Any other comments or questions? I did see Narelle, welcome, you just joined. I'm not sure, we started a little while ago, and we're close to wrapping up, but we'll be sending out the slides and the recording. So if you are interested in viewing or catching up, but we have got a couple more minutes still if people want to add questions or comments. And if I know, Chloe, you'd put in the chat earlier, you're doing fractions currently. If people want to share what they're currently teaching, what they're teaching next, happy to send out some more, resources that you can use where it's got the spot the mistakes and the misconceptions, etc. Happy to pass that through to you if it's of any use.
Yeah, we have some really great resources on fractions. I want to go through my computer right now and pull it up for you, but with a lot of visuals and sort of like worksheety type things that kids could do as well.
Chloe did just say that she loves the idea for a quiz. That'd be beneficial for a review lesson also. I'm leading up to an assessment for fractions and might have them create a review for this as a revision.
Yes, that's a great idea. Basically, I showed you in that Bloom's taxonomy pyramid, anything that gets them to that higher level of where they're analyzing, evaluating, and then creating, that's that top level of learning. And that's sort of when you're planning your lessons and how you're teaching, it's where you want to get your students. So anything where they're creating something and having to check it and look for what's wrong as well as what's correct is really going to help them. Can pull that up for you. A little pyramid. Bloom's pyramid.
So give people 1 more minute. And as I said earlier, and we've shared a couple of times, we will be sending this all out to you. So you have the slides. And as I said, if you want anything else, just respond to the email. If you've got questions for Kathy, etc., more than happy to pass them along. But thank you for joining. It was a small crowd, but I think it was great. It enabled us to have a more of a sense of what you wanted to hear, and also the things that you're currently doing at the moment and keen to try out. And there's Bloom's on the screen.
Yeah.
Cool. Well, if there are no further questions or comments, thank you all for joining us this afternoon. And thank you, Kathy, for sharing your expertise with us. I don't think people are going to mind finishing a couple minutes early if they can get on to the rest of the evening, go sort out dinner and get home and all those kind of things that are waiting for all of us. But it's almost the weekend and it's nearly the end of term and it's nearly Easter and all those fun things. So just thanks from Candace and Chloe to you, Kathy. So
yeah, great. Keep in touch. Let us know how it goes. I would really love to hear how it works in your classroom. And just keep trying. Don't be scared to try.
Cool. Hope to see you all again soon. Stay safe.
Bye.